What are the balanced chemical equations for the following? Oh, wow. Wow, indeed. This is going to take us a little bit of time. So, with that being said, balanced chemical equations for the following. So, when it comes to balancing equations, right? They're just going to actually list them all out, so bear with me here. A, B. It should be a way for me to actually snip this and paste it. Make it a lot easier. So, if I just did this to save us a little bit of time here. Okay. Nice, it actually worked. So, just exit out of this now, get back to our question. Okay, so we now have it nicely written down for us, and we're allowed to just go ahead and balance this. So, the way we answer these questions is actually, we want to make sure that the amount of I guess elements or properties in one side equal the amount of properties in the other side. So with that being said, we kind of have to go, I usually just bounce back and forth. There's probably a better way to do it, like when you list everything down. But you notice when you have molecules that are like bonded together, it's kind of usually better to just reciprocate the change on the other side as you go. So for this one, let's just start right away. We have FeCl and iron chloride, okay? And we notice that it's Cl3. So for this to balance it out, the 3 needs to be here. We need 3 chlorines to make up for the FeCl3. And we don't bother putting and oh, that's interesting actually. For this one, because interesting. I'm going to add some extra parts to this because I personally do not like how it's written. You will rarely see, don't worry, I'm going to erase that 3 after. Just want to make sure that it's big enough to where we can actually work with it. But I don't want to cover my question. So the reason why I didn't like that is because Fe would actually have a charge with it. So I don't know if they're supposed to do this, but because chlorine gas usually comes in as a gas with like Cl2. This is typically what chlorine would be. So I think they're referring that it's going to be an ion. And the same with this one as well. And these are both ions. So with that, now I can just put the 3 in front of this, okay? It didn't really work at first because if we're dealing with chlorine gas, this whole thing would look quite different. But I'm not sure if they want us to add the subscripts. Usually you don't touch subscripts. Okay. Well, I guess they do want us to touch subscripts. Because in this case, they gave us O2. And they still gave us Fe without a charge. I'm not liking that one bit. So I'm just gonna leave. I'm gonna leave this one as is and just solve it. So it says that we have 2 Fe's, right? So 2 here. We have 2 oxygens here, but 3 oxygens here. So we need the smallest common multiplier, which would be 6. So it'd be 3 oxygens here and 2 of the whole of the whole molecule. But because we just did that, Fe2 has to be changed because now we have 2 Fe2, so this actually becomes 4. Okay, so let's move on now. That's would be how you solve that one. For this one, exactly like I said, I kind of like to go I don't usually list everything at once because I like to go like one piece at a time. And for this one, I also like to note what type of reaction it is. So this one is like a combination. It just helps me keep track of things. This one's also a combination. So a combination is two things becoming one. Okay. This one is a double substitution. Okay. Because you notice that it was FeBr3 and H2SO4, but now they both switch their partners in a sense. So we have the SO4 here, right? But now we have 3 of them here. So we need at least 3 SO4 here. But because it was 3, but it's H2, right? We need 6 hydrogens in total. So there we go. And now because we have 6 hydrogens in total, let me make sure I'm doing this right. Yep, because we have 6 hydrogens in total, we need to balance out the bromine. So bromine actually needs 2 here. Okay. But now you notice that now we need 2 of these. Okay. But now as you notice, this is going to turn into SO4 times 3. We need 6 of these. Oh, is this even possible to balance? Because then when you double that, this also changes. Let me think about this one. Let me start first by just doubling the FeBr3. Or maybe you're just looking for 3 HBr. Because now it would be 3. But H2SO4. So let me just make this 3. Make this 6. Because you can't. Maybe it's half. No, that wouldn't work. 3. Or you have to now do this by the. I think it's asking us to balance because some of these might be balancing through the what's that called? The redox reactions. But I'm not sure. Let's actually see first, okay? Because SO4 is typically 2 minus, okay? And there's 2 of them, so that's minus 6 in total. Oh, yep. So now this has to be plus 6. And that means this has to be plus 6. And yep, this is still minus 2. Minus 2 plus 2. Hydrogen is plus 1. And then FeBr here. So that is so this is not a double substitution, this is actually a redox reaction. Redox. Okay. So wow. Well, this is gonna be a fun list to go through. I'm gonna enjoy this one. Where is it? And because Br3 is usually minus 1, plus 3, plus 3. So because it's a redox, you notice, and the reason why I say it's a redox because this iron here changed from plus 3, okay, to plus 6. And does that even happen in redox? Let me see. Redox reaction of this. Does iron ever go from plus 3 to plus 6? Let's see. No, I just want the list. Redox reaction equations. Nope. Redox reaction half equations. Okay, there we go. Half reactions, please. I just want the nice generous list, because I'll probably save it after this. Redox reactions, half equations sheet. I'm just gonna try this again. This is strange. There we go. Something like this. This is what I'm looking for. Nope. Where is good place I can look at this? I don't know why they can't just give a good list. Okay, well, I'll just look at this list in this picture here. Hopefully we can read it. It's a little bit small for my taste. We have iron. We have iron here. And we have iron there for Fe2 plus, Fe3 plus. I don't know if they even balanced this right. Because if anything, it should be Fe2 SO4. Because if I type in, oh, this whole question might be a mess. Because if I type in iron, so I've never seen iron go from +3 to +6. But if I said iron sulfate, if I said iron 3 sulfate, because it looks like it is. Yeah, Fe2 SO4 3. Wow. So they give us yeah. Okay. We're gonna go through these, but we're gonna really try to, we're gonna just ignore every possibility of a redox reaction. So we're just gonna say that it is still a double substitution, and we're balancing this. We're gonna also change, this is now, I'm gonna say this right now very clearly, that you don't typically do this. Actually, let me just see if there is a, so Fe3 plus 2 Fe6. Yeah, no, that is, yeah, no. Yeah, no, it can't go to 6 plus. So I knew something was off. Back to this question though. So we want a nice 2 right there, because that's actually what, so this thing just might have a bunch of H's with it. So when we're balancing this out, we're going to be really liberal and just, I guess, adding whatever we please, at least in terms of what makes sense in the real world. Typically, the only thing you'll be changing, as they indicated, is, you know, the part in front, the not the subscript, but in terms of like the prefix, that value there, that's usually what you should be changing. But we need this here because I've never seen that type of sulfate before. It's usually iron 3 sulfate, which is Fe2 SO4 3. Okay, so now back to that, when we actually try to balance it out, this no longer is an issue. Okay, you get 2, 6 there, 3, and now this is 1, because exactly now 2 is right there. And as you notice, just want to add it nicely there. As you know, exactly 2 Fe check, 6 Br check, 6 H check, 3 SO4 check. So this is what was missing. So let's keep our eyes open out for any other situations like that. So C4 H6O3 plus H2o C2 H4o2. So for this one, we want to start by maybe doubling this, because that's the only way for it to have 4 oxygens like the other side. Okay, so now we have 4 carbons, check. 8 hydrogens, which, yep, 6 plus 2, 8, and 4 oxygens. Yep, that's correct. That's all you have to do. And now let's move on. C2 H4 plus O2 equals CO2 plus H2o. So this one's actually a combustion, and this one again is a formation. That's the same thing as combination, really, but to keep consistent, I'm going to name all of them formation. Okay, combustion, reacts with oxygen to form CO2 plus H2o. This one, the last thing you want to balance is the oxygen, because as you can see, it comes from 2 different parts. So with that being said, though, so I guess for even the question prior, it would have been better to start with the carbons, okay, because that's the only one that doesn't come from 2 places. So by doubling that to match 2C2, everything just happened to match as well, which was good. So for this one, let's start again with the carbons, because they only come from 1 place. So C2 here, so we need 2 of these, right? And now the hydrogens, we have 4. So H2, we need 2 at least, okay? So we have 2C, which is C2, and 2H2, which is 4H, okay? And now we need to find out how much oxygen that is in total. So 2 of O2, so that means at least 2, plus 2O, that's a third of O2, because there's going to be 2 here and 4 there, so that's 6 in total, so that's 3 O2. So that's why we did the oxygen last, because it would have been really hard to balance based on just the oxygen alone. So now this one's another combustion, okay, and we have start with the carbons again, C4, so that's 2 over here. Oops, sorry, definitely miscounted. That's 4 over here, okay, and H10, so that's 5 over here. And now it does have an awkward extra oxygen. This is where it gets complicated, because now we're dealing with that one extra oxygen. So first, let's see if we don't have to make any changes and double anything. So right now we have 4 CO2, so that's 8 oxygens there, plus 5, so that's 13. So if we subtract that one lone one, that's 12, which is good, because actually what we want, one even number when we subtract that one oxygen. And so 12 divided by 2, that's 6. So this actually should work, because we have 12, 13 right there, and 8, yep, plus 5, 13 as well, 10 hydrogens, 4 carbons. Now this one is also another combustion, okay, so yes, this one was just written wrong, it looks like. Looks like now they're making a lot more sense. C2 H17, so that's 2 carbon here. Oh wow, that's not even possible. Well, we're just gonna solve it as it is, because the reason I say C2 H17 is impossible is because carbon literally runs out of bonding space. It can only fit maximum 6. Maybe that's supposed to be a 7, but that even wouldn't be enough. It needs at least at least 8. Let me see even what they even have for the answer. I don't even. Yeah. Okay, I mean, sure. With this imaginary made up molecule here, H17, meaning that we need to double this actually, because hydrogen come in pairs, so you can't have half of it. So it'd be 17 H2O here, 4 carbon there. And the reason why we double it exactly is because you want to make sure that you can actually put a whole number in your brackets. So that's 17. I'm gonna have to double a lot of things. 17 oxygens, okay, plus 8. So 17 plus 8 is 25. Once again, you can't do 25 over 2. So what you really need to do is now make this 25, yes, but that means everything got doubled to make up for it. So now we have 50 oxygens, okay? And to make sure that we have 50 oxygens, that's what we get. So now we have 16 from here plus 34 from there, and we have 34 H2, which is going to be 34 times 2, which is 17 times 4. So all this makes sense. I am not the biggest fan of these questions, but we're gonna just get through these. I might call it a night after this one, only because this was definitely a question that was a lot more, I guess. Actually, no, we'll keep going after this. Maybe get more in the zone after this one. But let's see. H2 SiCl2, H2O. And so for this one, you notice the only thing that doesn't really move around is a silicon. So there's 4 of them here, so you want at least 4 here. Okay. And what else does not? Well, I mean, the chlorine only moves to one spot. It's not split between 2 things. So if we have 4 of Cl2, that's 8 in total. So that's 8 HCl. Okay. So now let's see if everything else can balance out. So let's not touch the, oh, we don't need to touch the hydrogen yet, because the oxygen we can actually balance first. So there's only 4 oxygens here, so for this it would be 4 H2O. So let's see actually if all the hydrogens balance out. 8 plus 8, so let's see the hydrogens, that's 16 hydrogens in total, and 4 times 2 is 8, 4 times 2 is 8, so this checks out actually. And this is what we'd consider H2O to HCl. I guess this may be a double substitution, although it's not as clear because a lot of things changed. Yeah. So now for this one, what is this? They have zeros in there and ones, or is that 10? I think that is 10, 10, and 15. Interesting. Okay, let's just assume that's 10 then. Okay, so this is a 10, and silicon doesn't move, so we assume that this at least has 10. Okay, and oxygen 15, meaning that this is at least 15. Okay, so if we have 10, and then the chlorine, I think this is also a double. It's the same thing as above, but just more complicated. So 10, 3, that's 30. Okay. So with that logic, we should have 30 plus 10. We should have 40 in total of hydrogens. So 15 times 2, yep, 30 plus 10, 40. So this works. 15, 15, 1, and 30. And now this one is going to be, I don't even know anymore. I'm going to start naming them because let's see how this one moves. So the goodies of the carbon stay the same. Okay, they don't move. The NO3 becomes NO2. But we know that at least there's 3 of them. So it needs to shed, I guess, that amount. But wow, this has been an overall headache. Maybe we don't need to touch this because the C7 stays similar, But let's see now what happens in regards to our number of oxygens. So we have 3 times 3, we have 9 oxygens there. So 3 times 6 here, that's only, 3 times 2 here is only 6. So assume this has to be 3. Okay. Now to really find out that's the case, we need to add all the hydrogens. So 3H2, that's 6 hydrogens there, plus 6 hydrogens there, so that's 12 hydrogens in total. 9 here, plus 3, that's also 12 hydrogens. So we balance that one out. I think these ones might just be made up, but not really my favorite type of question, because especially when they're elements that can't feasibly exist, it kind of just ruins the whole point of it, in my opinion, just because at that point it's like, what am I balancing? I like to usually conceptualize and visualize the actual molecules and how they interact with each other. So having things like C2 H17 that doesn't really work in a natural state, it can be quite confusing. But with that, let's just move on. Let's see what we have here. We have only 1 sodium, so we don't have to change anything. 1 chloride, it looks like, but C5H8O2. We have only 1 O2. So what changed? H8. So that's 8 plus 9 plus 10 went to 12. But the carbons stayed the same. So the only way for that to happen is if these two were to double. And that's it. Because now we have 8 plus 9 plus 10 plus 11 plus 12, which is H12 right there. Okay. At this point, it's kind of just like I'll solve it as I go. I wish I could explain more, but because these things weren't like typical, real, actual equations, it made things a lot more complicated. So back to the top. Let's see how we did. See, I don't even understand that, because exactly, they just assumed, it seems, that chlorine was actually not an ion, but a gas, which you can do as well, but it would say Cl2 right there. They didn't even notify it, but 3Cl2 is the only way this balances out for 6, and exactly. So that is what they assumed there, which is why they have 2 plus 3 goes to 2. But I'm going to leave it as the ion, because that is definitely a viable option as well, considering that it didn't specify. So 4, 3, and 2, we got that right. 2, 3, 1, and 6 only works because I had to throw in that Fe2SO43. 1, 1, and 2, yep. 1, 3, 2, and 2, yep. 3, 2, 2. 6, 4, and 5, that's correct. 1, 11, 7, and 8. 7. So is that a C7? That still doesn't make sense. Yeah, no, that's because C7, H17. Because if you know, for a carbon, for it to be a full, it's going to be CnH2n plus 2, right? That's as full as it can go. So if it was carbon 7, it'd be H16 as its maximum, because it'd be 14 plus 2. So C7H17 still does not work. But that's the only thing that could happen, because it says it has 7 carbons on the CO2. But it also, or did it say C7H16? Oh, that's so confusing, because I think he just assumed it was H16. I'm not liking any of these whatsoever. because yeah, the reason why I say it's H16 is because they have 8 H2O here. So yeah, I don't know if it's the question that's incorrect or the way the person solved it that's incorrect. Yeah, who knows? Let's see here. 4, 4, 1, 8, okay. 10, 15, 1, 30, okay. 3, and then 3, okay. And then 2, 2, 2. So they make a table, they try to balance it out. I'm just gonna skip down and say this is incorrect. Not sure if it's the question or the answers, but things do not add up. So that was definitely a question.